In this video, we're going to be talking about how to convert between radians and degrees. So the first thing you need to know is what are radians and degrees. And really, radians and degrees are just ways to measure an angle. So kind of like how we measure distance in feet and meters, we measure angles in two different ways, radians and degrees. So this box on the right is going to be a really important one for you to know, that pi radians is equal to 180 degrees. Now, whenever you see radians, you are usually going to see a pi with them. So like this pi, that's a radian measure. And then these other two fractions are just important. Since pi and 180 degrees are equal to each other, if you put them into a fraction with one on the top and the bottom, it's just going to equal 1. So the big question that we're going to talk about here is if you have one angle measure, like say you have it in degrees and you want to put it into radians, how do you do that? So let's talk about that, going from degrees to radians. So here's your steps to convert. On the left you have your steps, and on the right you have an example going through the steps. So the first thing you're going to do is you're going to take your degree measure and you're going to write it as a fraction, which is super easy. You just put like 30 degrees over 1. Okay. Then you're going to multiply by pi over 180 degrees. Remember, this pi over 180, that's just equal to 1. So all you're doing is multiplying by 1, which is okay. And when you multiply those, you multiply the numerators together and you multiply the denominators together. Then you're going to simplify. So simplifying means like dividing the same number from the top and the bottom. And you're going to leave your answer as a fraction, and you're almost always going to have a pi in the answer. So in the example over here that I did on the right, I converted 30 degrees to pi sixths radians. So let's do a couple examples. So in number 1 down here, I want to convert 45 degrees into radians. So first, I'm going to take 45 degrees, and I'm going to turn it into a fraction by putting it over 1. Let me zoom in a little bit. Then I'm going to multiply by pi over 180 degrees. So when I multiply those together, I'm going to get 45 degrees pi over 180 degrees. And one thing that I do want to talk about here is that, do you see how there's a degree symbol on the top and the bottom? We can actually kind of just cancel those out. So we're really trying to get away from degrees, and this is why the degrees go away, because degrees on the top and degrees on the bottom means I can cancel those out. Okay, now it's time to try to simplify. So I am going to divide, well, let's actually come down here. We'll do that step down here. I have 45 pi over 180. And I'm looking for a number that I can divide 45 by and that I can divide 180 by. So in this case, I happen to know that I can divide the top and the bottom by 45. And maybe you don't know that. Maybe you just know that you can divide them by 5. You can start with smaller numbers. Just keep dividing by numbers that you can divide from the top and the bottom. So I'm just going to put the pi on the top, a 1 pi, and then 180 divided by 45 is 4. And you can totally use a calculator to help you do this division problem. So my answer is going to be pi fourths radians. Okay. All right, you can do the similar thing with, well, you can do the exact same thing if you have negative angles. So you can also convert negative angles, like the one in number 4, to radians. So you start the same way, make it a fraction over 1, and you're going to multiply by pi over 180 degrees. And you'll get negative 450 pi, 140 degrees pi over 180 degrees. And then here our degree measures will cancel each other out. And I will just have negative 450 pi divided by 180. Okay. I'm going to go ahead and do this next one in 2 steps, because I'm trying to simplify this fraction. So I'm going to start by just dividing the top and the bottom by 10. I know that they both end in 0, so they're both divisible by 10. So I can simplify this to negative 45 pi over 18. And now after I've divided by 10, I'm going to look at this fraction that I have, and I'm going to say, okay, is there anything else that I can divide by? There is. I can divide by 9. 45 divided by 9 is 5. 18 divided by 9 is 2. So that means that my radian measure is negative 5 pi over 2. Let's go through one more example together, and then I'm going to go ahead and fill in 2 and 5 for you guys. So go ahead and hit pause, try those ones on your own, and then come back and double check your answers. Okay, if you did number 2 and number 5 correctly, then you got 5 pi and pi over 180. So a couple of things to notice is that, like in number 2, there is a chance that the denominator of your fraction becomes 1. And if it is, then you don't have to write it. You can just write it as 5 pi, or whatever your numerator is. Also, like we saw in number 5, there's a chance that you can't simplify your fraction. If you can't, you just leave it as whatever you got. Okay. So we're going to do the same thing in number 3 and number 6, but we're going to practice sketching our angle in standard position as well. So first, let's go ahead and convert this to radians. So I'm going to multiply by pi over 180 degrees. I'll get 50 degrees pi over 180 degrees. We'll divide the top and the bottom by 10 to get 5 pi over 18. Okay, so that's my radian measure. So I'll go ahead and write that right there, 5 pi over 18. Now I want to sketch this angle in standard position. Now remember, standard position means that I'm going to start here on my x-axis, that's my initial side, and I'm going to go counterclockwise until I get to about 50 degrees. And that's going to be my angle. Now the reason that I wanted us to draw this angle in standard position is because I want us to recognize that this angle, we could say, is 50 degrees. And usually we actually put, I'm going to move this, we usually put that angle measure up here at the end of the terminal side. So it's 50 degrees. You could also say it's 5 pi over 18 radians. So graphing both of those would give you that same angle. Okay, I'm going to go ahead and do the next one. Go ahead and hit pause and try it on your own. All right, your answer to number 6 should look like this. To get to 720 degrees, you have to complete 2 full circles. So your terminal side and your initial side are the same. And as you convert it to radians, it just turns into 4 pi. Okay, hopefully you're feeling really confident about converting from degrees into radians. Let's take a look at what it would be to convert from radians to degrees. And this is going to be really similar to what we just barely did. So I'm going to start with a radian measure, and I'm going to multiply by 180 degrees over pi. So notice this is the same fraction, it's just kind of switched. The numerator and the denominator have switched. You're going to multiply by that, and then you're going to simplify, and you're going to divide. Okay. So let's look at the example over here. I have pi thirds. I multiplied by 180 degrees over pi. I'm left with 180 degrees pi over 3 pi. In number 2, the important thing that I'm doing in my simplifying is I'm canceling out the pi. So you will usually get a pi in the numerator and the denominator. So you can just cancel those out. And then your final answer is just to divide. So turn this fraction into a decimal, or in this case, just a whole number. So you don't have to worry about like dividing the top and the bottom by the same number. You can just punch this into your calculator and get a decimal. So let's go ahead and take a look at what it would look like to convert 3 pi over 4 to degrees. So I'm going to start by multiplying by 180 degrees over pi, which is going to turn into, 3 times 180, 540 degrees pi over 4 pi. I'm going to go ahead and cancel my pi's out. So I'm just left with 540 degrees divided by 4. Then I'm just going to punch that into my calculator, and I get 135 degrees. And that is my degree measure. Okay. And just like with degrees, we can convert negative radians to negative degrees as well. That's what we're going to do in number 4 here. I'll go ahead and multiply by 180 degrees over pi. So I will get 360 degrees pi over 3 pi. Go ahead and cancel out those pi's. And then 360 divided by 3 is equal to 120. Make sure you put that degree symbol if you're in degrees. Okay. All right, I'm going to go ahead and practice on 2 and 5. So hit pause, do a practice on your own, and then come back and check your answers. So if you did these ones right, you should have gotten 157.5 degrees and then 1080 degrees. So one thing to look at is that in number 2, we did end up with a decimal. That's perfectly fine. And in number 5, I changed the 6 pi into a 6 pi over 1 before I started multiplying. Okay, let's do a couple more examples of converting and sketching. So what we're going to do is we are going to convert these radian measures into degrees, and then we're going to use those degrees to sketch the angle in standard position. So I'm converting 10 pi over 17 to degrees. So I will start by multiplying by 180 over pi. So one thing that you can also do is you can cancel your pi's out in this step if you want. Kind of save yourself a step. Okay. Then I'll have 180 times 10 is going to be 1,800 divided by 17. Punch that into your calculator. And you're going to get 105.9 degrees. So that is my degree measure. So let's go ahead and sketch that in standard position. So I'm always going to start here at my x-axis. I'm going to go around until I hit 105. I hit 90 right there, and then I just go a little bit further. And that is my angle. So I'm going to say that angle is 105.9 degrees, or it's 10 pi over 17. Okay, those would both be acceptable and correct answers. So go ahead and try 6 and then pop back on and double check your answer. All right, the answer to number 6 is that the degree measure is negative 225 degrees, and the angle sketched in standard position is there on the bottom right of the screen. Don't forget that when you have a negative angle and you're sketching it, you go the opposite direction. Okay. Hopefully this was helpful as you learn how to convert between radians and degrees. You may have asked yourself your question, why should I even care about radians versus degrees? Why can't we just have one? You'll see that as you move further forward in math, it's nice to have both. Sometimes it's more useful to deal with degrees, and sometimes it's more useful to deal with radians.